Okay, Kevin, I'm going to ask you to go on to your next talk. Thank you for a fine presentation.
All right, thank you. Let me share my screen again. So this one's a little short. It's on stellar multiplicity and asteroid occultations, mainly multiple star systems. That's what I mean by stellar multiplicity. This was work that I had a student working on, and so the work went on for 6 months, and I have to say I learned a lot. She would come in with telling me that what I wanted her to do was it couldn't be done, and etc. But in the end, I gave her a grade for the research, and I haven't heard from her since. So this is, it was work that was not quite finished, and so I only have about 10 slides. So this one will be short. But so the question, we have double stars, triple stars, whatever, and these are a bit of a pain for us, to the point where I think people want to stay away from these systems. I kind of have a different view. I think instead of running away from them, we should be running towards them and try and understand them better, because at some level they're always going to be there. And this is from a paper in 2013. I'm sure there's some Gaia discussion about this since it's a bigger data set. But the bigger issue, when you ask the question is, when you look up in the sky and you look at a star, how many stars are in that point of light? And that's going to be the let's see, the frequency of multiple systems. That's going to be the MF. That's going to be the blue triangles here, down here. And what are we plotting here? We're plotting the frequency at which something occurs versus the stellar mass of the system. And here's the solar mass right here, and it's like 50%. So that's kind of high. You go down to the smaller systems, they tend to be more loners. You go to the larger systems, and they tend to have more companions. And that's the red is what's called the companion frequency. So if you look at a system with 10 solar masses or more, there's usually one companion. On average, there's about one companion, which is kind of surprising, but that's the way it is. So this is, again, stellar masses down here. It's the mass of the system. So there is, there is some dependence upon the on the mass of the system, but it's still pretty high even for solar mass stars. So you look up in the sky, half of what you're looking at are, no, that's not quite right. I always get that wrong. Half are, yeah, roughly, not quite half are double star systems. So there's a lot of them. And I got motivated on this by another occultation that we did. This was the rock is 3981 Stadola from December of last year. Expectation is 2.2 seconds. Look at the reliability here. 12.3. That's the Gaia DR3 reliability. RUWE is 12.3. The duplicated, there is no duplicate source, non-singular source tag in the Gaia data, which makes sense because it's 12.3 RUWE. This is, again, it's from the WDS. This is from the Washington Double Star.
Can I interrupt here, Kevin?
Yes, please, David.
That duplicate source flag on that flag is actually a Gaia duplicate source flag.
Where's it coming from?
It's held in the occult Gaia file, and when I created that file, the reliability flag was retrieved, as was the duplicate source flag. And that duplicate source flag, I just double checked with the Adelheid one, it's from the Gaia data set.
Okay, when I look at Visier, I'm looking at the NSS flag, which is the non-single source, and it's either not there or it's 0. So I'm
Let's
confused.
deal with that. Let's deal with that separately. But I can assure
okay,
you
so
that
okay, yes, actually, I would love to know the resolution of that. Anyway, moving on. Only a couple more slides. So this was the I don't think I have the light curve here, but this was the event coming out of occult. It was a little short, but it was late. It was late by about 5 seconds. And this was our chord. This is the only chord seen in the system. It's clearly a double star system, and the predicted path is not even on the graph here. I think it's way down south from where from the graph itself, because it's just it was a little too far off. The stars, if I go to the Washington double star catalog, I see that there are 2 stars listed. One's magnitude 9.9, one 10.9. And it was the light curve, which I don't think I put in, is consistent with the brighter of the 2 being occulted. So I was hopeful that maybe I could get some information on where these stars were, or to actually get a better idea of exactly where that occultation took place, because it certainly wasn't at the star's quoted position, the center light of the position. From the Washington double star catalog, it's 400 milliarc seconds separation, which would correspond to a maximum difference in time of about 48 seconds, I think, for the star is what I calculated. This is, so going to Simbad, which I usually get via Visier, but it's kind of it takes me a while to get here to find the star. But this is the star. There's a WDS number here. There's the Gaia DR2, DR3, and but anyway, this is the star. So okay, WDS. Let's go look. And now I don't know where the raw data are for Washington double star catalog is. If someone can help me out there offline, that'd be great. But here is the summary entry for that double star, and the data set ranges from 1972 to 2013. And it's not much of a data set. If that number 3 that you see afterwards there, this is the number of observations. Oops, sorry about that. 3 is the number of observations. So there is no data. This is the education. This is my education. There's not as much information on these guys as I would have expected, at least on some of them. And I'm a little surprised by that. And now with time, that should change because of the Gaia data set, but presently we're in limbo and until there's more data available, so that Gaia can resolve a lot of these guys, is my assumption. Anyway, so I'm kind of gung-ho. I was gonna, at this point, I was gonna go into some analysis that my student did, but unfortunately we didn't finish, and so I won't do it. But I was going to give you some numbers on how many of the double stars in the occult database are actually Washington double star stars, and it's not all of them. And there's another number that's also interesting, which again I don't have, which is, of all the stars, how many are double stars? And the number isn't of all of the non-double stars in the system, how many are in the Washington double star catalog, and it's a non-zero number. It's actually a larger number than I would have thought. Unfortunately, I don't remember what it is. This is an event that's coming up. Now, I did not pick this on purpose. This is the same, this is in the evening prior to the IOTA observation of the one that's going to go across the United States, and I'm forgetting Inter Omnia, I believe is what it was.
Yes.
Yes, and but so this is the night before. That one's, I believe, in the morning. You know, oh yeah, going back to this, what I should say is I also looked for, in the Stadola event, I looked for maybe there are some lunar occultations for this particular star. None have been observed. However, I do want to point out that in December of 2028, there will be some lunar occultations of this star in Siberia. So I make a recommendation to the board that maybe we do a trip to Siberia in December of all months, 2028, to observe that. That's a joke, of course. Sorry, my hand fast trigger today. So this is I'm looking for some practice events for the Adelheid event, because I really want to find another chord on that moon. And so this was one that is occurring between then and now. There are a few others that are coming out, but what's interesting about this one is that it is also a variable star, or not a it says variable star. It's a double star system. It's actually an eclipsing binary. It's got a high RUWE, and again, I am not running away from these. I am running towards these. We need to, I think we need to be proactive on some of these guys, and these actually represent opportunities. This is the star for that event that's coming up in my neighborhood, and it's an eclipsing binary. The Atlas telescope, asteroid telescope, is they have detected it as a eclipsing binary, and the Catalina Sky Survey telescope also has information on these, and that unfortunately I was not able to get in time to show what that is, but it's a eclipsing binary system with the separation, a radius separation of 0.13 arc seconds, which is about 100 kilometer maximum displacement for this particular event. And so there should be two shadows of this particular asteroid. Exactly what the orientation of that is, I don't know. I'm hoping to figure that out before event time so that we can maybe detect both of those shadows for this particular event. And so that's all I had on that one. Is a little shorter, but anyway, there are new double multiple star system databases. People are publishing, a lot of these surveys have been publishing this information over the past 5 years. And so there are some dynamical parameters available now, I think more so than just the Washington Star Catalog. I think that would be beneficial, and this is again an avenue I'm pursuing, is to try and get the asteroid astrometric data more accurately depending upon the stellar positions. And so that's Stadola event, it's still not bad. The astrometry is still not bad, but it could be like a factor of 10 better if we can nail down where those stars actually were during that event time. So, and that's all I'm going to say on that right now. And so I'll let me stop sharing and release it back to you.
Any questions for Kevin?
This is David. I just point out, sent a thing on chat that, Gaia DR3 has a huge database of stellar duplicity information, including, I think, about 150,000 double star orbits and some larger number of just double star detections. So in the early release and in DR2, they just had the duplicate source flags or didn't really clearly resolve the double stars to their satisfaction to do release data on them. But I think DR3 did, the final release of that. And we should do better with the next release, DR4.
Can I
Yes.
add to that? There's just in the last week or two, there's been a new catalogue based on the Gaia data, which has got, I think it's about 60,000 of those stars with decent orbits. And it's my intention to make that data set available through Occult.
That'd be great.
Yeah, that will be a good development. Okay, well,
We had-
Dave
Yeah.
Harold, it is your turn for the next talk.